You probably use them dozens of times a day, honestly, without a second thought.
Oh, absolutely. Yeah.
Like checking the weather before you head out, or maybe logging into some app with your Google
We're
account.
paying for something online with PayPal. Right.
Exactly. All those things, and way more, are being quietly powered behind the scenes by something called an API.
Yeah, it's like the invisible glue or maybe the hidden plumbing of the internet. It connects everything. These aren't just little features, they're fundamental now.
Totally fundamental. And, that brings us right to the main point of this deep dive. What is an API, actually, like in plain English?
Right.
So our mission today, we're going to cut through all the tech jargon. By the end of this, you'll get what an API is, how it works, and really why it's this invisible cornerstone holding our digital world together. Simple terms, real examples.
We're aiming for those aha moments, definitely. Because they're everywhere, but they're kind of designed not to be seen, operating underneath almost every single thing you do online.
All right, let's get into it then. We've all seen the letters, right? API, it stands for Application Programming Interface.
Yep.
But, okay, beyond just spelling it out, what does it do? At its core, it's kind of like a specialized messenger, isn't it? A negotiator between different software bits.
That's a great way to put it. The messenger analogy is perfect. Uh, think about being in a restaurant.
Okay.
You're the customer. You want some food. The kitchen, well, that's the complex system, right? Where all the cooking happens, ingredients are stored, all that complex stuff.
Right, and I definitely don't just wander into the kitchen myself.
Exactly. You don't need to know the chef's secret recipe or, where they keep the pans. That would be chaos.
Total chaos. You talk to the waiter.
Precisely. The waiter is your API in this situation. You give him your order. That's your request. The waiter takes it to the kitchen, makes sure they understand it. The kitchen prepares the food, and then the waiter brings back your meal. That's the response.
Okay. So I get what I want, the food, without needing to understand anything about how the kitchen actually works.
Exactly. The API is that interface. It lets two different pieces of software talk to each other in a structured way, securely, without exposing all the messy internal details.
It's about setting clear rules for interaction then, keeping things neat and tidy between systems.
That abstraction is absolutely key. It means the app making the request, or you, the user, you aren't bogged down with complexity you don't need. And it protects the system providing the service, too. It's efficient.
Okay, that makes sense. The digital waiter idea helps. So the next obvious question is, how does this waiter actually, do its job behind the scenes?
Right.
Let's use another example, maybe the weather app on your phone.
Perfect example. When you open that app, it obviously doesn't have all the world's weather data stored on your phone. That'd be impossible, right?
Yeah, my phone would explode.
Probably. Instead, when you open it, the app sends out a very specific request to, say, a weather services API. That API is like the front door to huge databases of constantly updating weather information. It takes your app's request, figures out what it needs, temperature, forecast for your location, and fetches it.
And then it sends that information back.
Exactly. It sends back a nicely structured response. Your app gets that data, understands it, and then displays it on your screen, sunny 25 degrees Celsius.
So I just see the final result, but there is this whole quick conversation happening in the background between my app and the weather service managed by the API.
Precisely. And we can break down that interaction into like three main steps. First up is the request.
Right.
The app sends this to the API. It usually specifies something called an endpoint, basically the specific address it needs to talk to, and parameters, which are the details, like weather for London or forecast for tomorrow.
So back to the restaurant, it's not just food. It's, I want the steak, medium rare, with fries. Being specific.
Yeah. Exactly that level of specificity. Okay, second step. Processing. The API gets the request, understands it, and then goes and talks to the main system, the database, whatever holds the actual information, and retrieves it.
Gotcha.
And third, the response. The API packages up the information it found, usually in a standard format like JSON or maybe XML. These are just ways to structure data so computers can easily read it and sends it back to the app that asked for it.
And then my app makes it look pretty for me.
That's the final step. Your app interprets that data and displays it.
And the amazing thing is, for us, the user, this whole process is invisible. We just tap, wait a second, and boom, there's the weather. The API does all the heavy lifting.
It really does. It's a very elegant way to handle communication between different specialized systems. They can stay separate, but still work together perfectly.
Okay, so APIs are these messengers, these waiters, but you mentioned they aren't all the same. There are different types and even different styles.
That's right. We can classify them based on who gets to use them, basically. First, you've got open APIs or public APIs.
Okay.
These are out there for pretty much any developer to use. Think of the Twitter API or Google Maps API. Companies publish these to let others build cool things using their data or services. It encourages innovation.
So that's how, like, a third-party app could show tweets or integrate a map.
Exactly.
Hmm.
Then the opposite end is private APIs. These are strictly internal. A company uses them to connect its own different systems together, maybe linking their sales software to their inventory system, not for public use.
Makes sense. Keeps internal stuff secure.
Then there are partner APIs. These are kind of in the middle. They're shared, but only with specific trusted business partners, maybe for integrating supply chains or offering joint services. It's controlled access.
Okay. And you mentioned one called composite APIs. Those sound interesting.
Yeah, composite APIs are pretty cool. They act like a sort of master coordinator.
Mhm.
A request comes in, and the composite API might actually call several other APIs behind the scenes, maybe one for user info, one for product details, one for shipping options, bundles all that data together and sends back one single unified response.
Ah, so it simplifies things for the app making the request. It doesn't have to juggle talking to multiple different APIs itself.
Exactly. It hides that complexity. Very useful for building complex user experiences smoothly.
That does sound powerful. And what about those different styles you mentioned, like different ways of building them?
Right. Different architectural styles. The most common one you'll hear about by far is REST, which stands for Representational State
Not
Transfer.
the rest. Okay.
REST APIs are generally simple, they're scalable, and they use the standard HTTP methods, the same get, post, put, delete stuff your web browser uses. They're kind of the default choice for most web-based APIs today.
So pretty straightforward, widely used.
Very much so.
Yeah.
Then you have an older style called SOP, Simple Object Access Protocol.
SOP.
Yeah. SOP is typically XML-based and has much stricter rules and contracts about how messages are formatted. You often find it in more traditional enterprise settings, maybe banking or industries needing high security and guaranteed transactions. It's generally seen as more complex than REST.
A bit more heavyweight, maybe, but sometimes necessary for specific needs.
That's a good way to put it. And then there's a newer style that's gained a lot of traction called GraphQL.
GraphQL.
The big thing with GraphQL is flexibility for the client, the application making the request. Instead of the API deciding exactly what data to send back in a fixed structure like REST often does, GraphQL lets the client ask for exactly the specific fields it needs and nothing more.
Oh, interesting. So if I only need a user's name and email, I don't get their whole life story back with the response.
Precisely. This can be really efficient, especially for mobile apps where you want to minimize data transfer. It gives the front-end developers more control.
Okay, wow. So lots of different flavors. And this is where it gets real, right? Because these different types and styles are working behind the scenes in stuff we use constantly.
Absolutely.
Yeah.
Let's connect it to those real-world examples. We mentioned Google Maps. Think about Uber or DoorDash. They didn't build their own global mapping systems from scratch.
Sure.
They use the Google Maps API. That API gives them the maps, the ability to calculate routes, show traffic, estimate ETAs.
Yeah.
They build their service on top of that powerful mapping capability provided via the API.
It's like building with high-tech Lego bricks someone else made.
That's a perfect analogy. Another huge one. Online payments. When you buy something and use PayPal or Stripe,
Yeah.
the shop you're buying from, it doesn't actually handle your credit card number directly. That would be a massive security risk and regulatory headache for them.
Right. I always wondered about that.
Instead, when you hit pay, the website uses a payment gateway's API, Stripe's API, PayPal's API. It securely sends the payment details to that API. The API handles the actual charge with the bank or card network, figures out if it's approved, and just sends a simple success or fail message back to the shop's website.
Ah, so the API acts as this secure middleman, keeping my sensitive data away from the merchant's main system.
Exactly. It's crucial for security and trust online.
Definitely. Okay, another one, those login with Google or login with Facebook buttons everywhere.
Classic API use case. That's all about authentication. Instead of making you create another username and password for, say, some new forum or app, the site uses the Google or Facebook API.
How does that work?
You click the button, you get briefly redirected to Google or Facebook to confirm it's you, and then they send a secure token back to the website via the API, basically saying, yep, we know this person, they're legit. The website never sees your actual Google password.
So much easier than remembering hundreds of passwords.
And more secure, usually. It centralizes your identity management.
Okay, one more of those big travel sites like Expedia or Kayak. where you can compare flights from loads of different airlines at once.
Yeah, brilliant example of API orchestration. Those sites don't have direct deals or databases with every airline.
So how do they get the prices and times?
They use the public APIs provided by the airlines themselves, or sometimes through large aggregators called GDS systems, which also have APIs. When you search for a flight from London to New York, their system sends out requests simultaneously to the APIs of British Airways, Virgin Atlantic, American Airlines, etc.
Wow.
It collects all the responses, prices, times, availability coming back from those different APIs, and then organizes and displays them all for you in one place.
That must be incredibly complex behind the scenes, but the API makes it seem simple to me as the user.
That's the magic of it. It aggregates distributed information.
So stepping back then, why is this all so important? Why are APIs considered so indispensable? It's more than just convenience, right?
Much more. Fundamentally, APIs drive efficiency. They let all these different systems talk to each other smoothly. Imagine the internet. Without them, it would be incredibly fragmented and slow. Information silos everywhere.
And what about for the people building this stuff, the developers?
Huge time savings. Massive. Like we said with Google Maps, why would every delivery app build its own map? It makes no sense. Developers can grab an existing service through its API and integrate it in hours or days instead of spending months or years building it themselves.
So they can focus on what makes their app unique rather than reinventing basic functions.
Exactly. And that directly leads to the next big point. APIs fuel innovation. They act as building blocks. Small teams, startups, they can suddenly access incredibly powerful capabilities, mapping, payments, AI analysis, whatever, just by using an API. It levels the playing field.
It allows people to combine existing services in new and creative ways.
Precisely. Think about how many businesses were built because APIs like Google Maps or Twilio for communications existed. They enable entirely new business models. It fosters this amazing ecosystem.
So really, APIs are kind of powering the entire modern internet, from cloud computing platforms, which are heavily API-driven, to AI services, to the Internet of Things where your smart fridge needs to talk to, I don't know, the grocery delivery API.
You got it. APIs are the connective tissue. Without them, the dynamic, interconnected digital world we live in just wouldn't function. It would grind to a halt.
Okay, so they're incredibly powerful, fundamental, but there have to be downsides, right? Challenges, things to watch out for.
Absolutely. It's not all seamless magic. There are definitely considerations. One common one developers run into is rate limits.
Rate limits.
Yeah, API providers often limit how many requests you can send in a certain time period, like maybe 1,000 requests per hour. This is to protect their own systems from getting overloaded, accidentally or deliberately.
So you can't just hammer their server endlessly.
Right. If you exceed the limit, your request might get temporarily blocked. It ensures fair usage and stability.
That makes sense. What else? Security must be huge.
Oh, security risks are paramount. Because APIs are gateways into systems, often handling sensitive data, they are prime targets for attackers. If an API isn't properly secured, it can lead to data breaches, unauthorized access, all sorts of bad things.
So how do they secure them?
Well, there are various methods, things like requiring API keys, which are like secret passwords for applications, or using more complex protocols like Oath, which you see with those login with Google buttons, allowing secure delegated access without sharing the actual user password. Strong authentication and authorization are critical.
Like a digital bouncer, checking IDs very carefully.
Exactly, a very vigilant bouncer.
Yeah.
And another challenge is dependency.
Meaning?
Well, if your awesome application relies heavily on, say, 3 different third-party APIs to function, what happens if one of those API providers suddenly shuts down, or changes their API significantly without warning, or starts having major performance issues?
Your app could break even though your code is fine.
Precisely. You're dependent on external services that are outside your direct control. Managing those dependencies, having fallback plans, understanding the risks, that's a big part of building robust applications today.
So it's a trade-off. You get the speed and power of using someone else's service, but you also inherit some risk and lose some control.
Exactly. It's a constant balancing act in software architecture. You need to think about resilience.
Got it. Well, this has been incredibly insightful. We've really unpacked APIs, application programming interfaces.
We have.
I started seeing them in everyday things like weather apps, logins, payments, and we've learned they're essentially these vital digital messengers, the invisible glue connecting everything online.
Making it all work efficiently, enabling innovation, ensuring security, mostly.
Right. From booking travel to how cloud services operate, they are truly fundamental. Hopefully you listening feel much more clued in now about these building blocks working away behind the screens you use daily.
Yeah, hopefully it demystifies some of that background magic.
And that leads us perfectly into our final thought for you to chew on. Given how absolutely central APIs are now to our apps, our businesses, global systems, everything, what do you think comes next? What new possibilities or maybe what new challenges might emerge as even more of our world gets connected and automated through these powerful digital messengers?
That's a great question to ponder.
Definitely something to think about as you go about your digitally connected day. Thanks for joining us for this deep dive.